Hello, my algebra superstars. Today we're working on some notes and some work, working with that quadratics and vertex form that we introduced yesterday. We did the notes on. So remember, this was our equation right here. We had f of x equals, and then it was a times x minus h squared plus k. And remember, hk is just the vertex. Okay, that's the vertex of the parabola. Whereas a, if you remember, a does one of three things. It could either do, one, make it narrower. Two, it could make it wider. Or three, it can flip it. Okay, so there's three possibilities there with a. Now, if I want you to take a close look at this formula again. If we look, a and k, they're both positive. They leave them kind of positive. But then if you look at h has a negative. So what happens with h is that if we ever put some information in for h, we got to make sure we change the sign of h. Okay? So I'll show you what that means in just a second. Whereas the other ones, we don't change the sign. They stay exactly what we expect. So right here in part one, we are given a vertex and a. Okay, so we're given both the vertex and a, and then what we're going to do is we're actually going to write the equation. All right, so we're going to write the equation from the vertex and a. So if we look at this, we're actually not given a vertex in this case, but what we are given is the graph. It's over here. So what we can do is we can find the vertex. So remember, the vertex is just that highest point in this case. It's either the highest or the lowest. In this case, we've got a maximum right here. Okay, so with that maximum, we can write the value. We've got negative 4, 8. So there's our vertex. Now to write the actual equation, what we're going to do is we're going to say, okay, we're going to rewrite this equation up here. But we know three pieces. We know a, we know h, and we know k. So we're going to plug all three of those pieces in. F of x equals, and then that's going to be a value is negative 1/2. Okay, parentheses x. Now, it's minus h. So we got to make sure we've got a negative 4. When it comes in, it's got to change sign. So a negative 4 becomes positive 4. Okay, always make sure the one in the parentheses, that one changes. So that's plus 4, and then in the end, plus k. Notice 8 was positive, still positive. Okay, that one does not change. And that's it. That's the equation right there. We're good. Okay, that's all we're looking for, just the equation in this case. All right, number 2 we'll do together as well. Here's another example. Number 2, you got a vertex of 3, 7, and this time our vertical stretch of 2. That just means that that's our a value. It's 2. Okay, so we'll do the same thing. We've got f of x equals, now a is 2, so we'll plug in 2. Right? And then parentheses x, and then now we've got positive 3, so it comes in, changes signs, minus 3. Okay? Then we're squared, and then that'll be plus 7. Okay? And that's it for that one. So now what I want you to do is I want you to pause our video. Go ahead and pause the video, work on number 3 and 4, and then once you're done with 3 and 4, then you'll be ready to move on to the next part. So go ahead and give the video a pause, and then try those ones out. All right, so now you're back. You're ready to work on these ones. We've got part 2 over on the right. Part 2, now we're actually given the equation. We're given the equation, and then what we're going to do with it is we're going to find the vertex, we're going to find the a value, we're going to graph that information that we have over here, and then what we're going to do is then we're going to talk about the transformations. Okay, so this will be the transformations. Okay, what are the transformations? In this case, there's going to be 2, so we'll have 2 dots. Okay, so first of all, a value, that's the easiest thing. It's this coefficient right in front. That's just 2. Okay, that part's pretty straightforward. But then when it comes to the vertex, that's where it gets tricky again. Just like how on the other side, when we put our h value into the equation, it had to change signs. When we do the opposite, when we take it out, that -6 is going to come out as a +6. Okay, so we got to make sure that we change signs going in and out. Okay, now the y value here, we don't see anything out here. There's no plus something, no minus something. So when there's nothing there, we can assume it's saying +0. So we'll go ahead and say that's 6, 0. Okay, so that's good for that. Now we have our vertex and we have our a value, so now we're ready to graph. So now we're ready to graph this thing. Now, I'm not expecting that you'd be able to graph this entirely on your own, like that this is something you're just going to kind of come up with. Definitely use our resources when we're going to graph these things. So what I want to go ahead and do is I have an equation. It's y equals, right? So I can come over here and come to my calculator. Come to my calculator here, and we can plug in our equation into y equals. So we're going to make it look just the same. So that's 2 parentheses. I've got x minus 6, and then that's squared. Okay, and we'll leave out the +0 because that's what I added. So we can leave that off. So then we go second. Graph takes us to our table, and we want to go to these values that make sense, that can actually fit. These top ones are not so great. They don't fit on our graph, but these ones do. Okay, these ones definitely do. So we got 6, 0. Oops. That's 6, 0 right there. I did these on the wrong side. 6 zeros right there. And then I've got, what is that, 7, 2. Which means I got 5, 2, and then 8, 8. And which means I got 4, 8 on this side. Okay. All right, there's our graph. From there, what I want to do is I want to actually graph another graph on here. This is going to be our parent function. I want to see, whoops, that one's the wrong one. Let's see here, then 9. What I want to do is I want to see what transformations happened to get from my green one, my parent function, so this is y equals x squared, to get from this one to this one. And like I said earlier, there were two things. There's two things. One of them is that we shifted to the right. You can see that, right? Look at the vertex. Goes from here, shifts over to the right 6 spaces. So we're going to say right 6. Okay, that's our first part. Now the other thing that happened is this coefficient here in the front, 2, this a value of 2, when that a value is bigger than 1, it makes it narrower. Okay, so this is narrower. Right? You can kind of tell if you look at the green one, it's a little bit bigger than the purple one here. Purple one was squished a little bit. It's narrower. Okay, let's do another example together, and then you guys can do the third one on your own. Let's look at this one now. Same deal. We've got the equation. What we're going to do is we're going to come up with the vertex and the a value. Okay, so our vertex, let's start with that this time, is going to be, that's a +2 inside. We got to change it. It's going to be -2. Okay. What's on the k? We actually see it this time. That's a -3, so we're going to say -3. So -2, -3 here. Okay. The a value, it's just that coefficient out front. That's going to be 5. Okay. Again, I've got both of those just right from the equation. That's why we call this one vertex form, because we actually see the vertex in the form. So now I'll graph my vertex, -2, -3 right there. And then I'll bring out my trusty calculator again so I can go ahead and check that out. Let's type that in. 5 parentheses x + 2 squared, and then that's -3. Okay. And so then we'll go ahead and hit second table, take us to our graph here, or to our table. Doesn't look like we have a whole lot of points that we can use. Check it out. Negative 3, 2. So negative 3, 2 would be right here. And then I've got negative 1, 2 would be right here. This guy's going to be super skinny. Okay, really narrow on this one. Because that's all that can fit, is just those. Okay, so we got something like that. Let's go ahead and put that parent function in here again. We can see what the differences are. So our parent function, 0, 0, 1, 1, negative 1, 1. We got 2, 4, negative 2, 4. 3, 9, negative 3, 9. And then there it is. You can already see how skinny or how narrow our purple one is now compared to our parent function. Okay, this guy's y equals x squared again. All right. Okay, this time there's actually 3 transformations though. So our transformations. Okay, transformations, there's 3 of them. One of them, we can see it. It's so obvious. It's narrower, like crazy. Okay, way narrower. Okay, now if you look at the vertex, we go down, and then we go to the left. So how far down do we go? Well, we go down 1, 2, 3, and we go to the left 1, 2. And that's it. That's all for that one. So again, go ahead and pause the video. Now you can work on number 3. Okay, you got the idea. Make sure you list your transformations that are going on here with number 3. Let's see. Let's do them somewhere where we can fit them. Let's put them over here. We can do transformations. And there's going to be 1, 2, 3 of them. Okay, so make sure you include your transformations along with your vertex A value. Graph that thing. All right, welcome back, part 3. Part 3, we've got, this time we're given a table. We're given the table, we need to figure it out. So you guys should know by now, you see a quadratic table, you are making that rainbow every time. I want to see that rainbow. Now, that means our vertex is sandwiched in the middle. Negative 2, negative 3, just like that. Okay, now from here, I'm going to extend my table because this 6 is missing a buddy. There's its buddy. Okay, now 6 and 6 match. We continue the pattern here. Negative 1, 0, that's going to be 1. Okay, so there's that. Now, as far as opening upwards or downwards, let's look at this y value here. If you look at the y value, that's a negative 3. It's either the biggest or the smallest number. If it's the biggest, then that means it's going to open down because all the other numbers are going to be smaller than that. But if we look, all of these numbers, negative 2, 1, 6, those are all bigger than negative 3. So this is actually a minimum. If we draw a picture, it'll be negative 3 right here, and then all the other ones are going to be bigger than this. That's opening up, right? This is going to be a minimum. Okay, so it's good to draw yourself a little picture. Oh, that's my minimum. It's going to be opening up. You can say it's opening up. We're good to go. Same kind of deal right here. 1 comma. So when x is 1, y is what? Well, we just did that. We extended the table. X is 1, y is 6. Okay, so there's that one. Now, as far as the domain goes, domain is always all real numbers. Okay, we can also use that big R thing that I showed you guys. Big R. Okay. The tricky one is range. Tricky one is the range. Again, we're going back to that y value of the vertex. It's going to be y. Okay. We've got that y value of the vertex. Y. And then we get the y value of the vertex, negative 3. And then we're either going to be greater than or equal to or less than or equal to. Now, the way we choose, so it's either one of these, greater than or equal to or less than or equal to. The way we choose has to do with the rest of these values. Since we're opening up, okay, all of them are going to be bigger. Greater than, bigger, that's what we want. We don't want less than. We want greater than or equal to. So this is our range right here. Okay, that's our range. Y is greater than or equal to negative 3. All right. Let's do another example together, and the rest is yours. Okay, this table's a little different. sideways. Here's our x's, here's our y's. So let's make that rainbow. Got -3, -3, -6, -6. Let's extend the table out. We got -11 coming over here with -4 looks like the pattern there. And then we got another one. We got to sneak in here somehow. That's a -18 and a -5. Just barely got those ones in there. Okay. Now, there's our point that was in the middle, so that's our vertex. That's our vertex. That's going to be -1, -2. Okay, and then again, we're looking at for opening up or down. We're looking at this y value here in the vertex, -2. Now, -2. Let's draw a -2. That's right there. Now, are these getting bigger or smaller? Well, they're getting more negative. -3, -6, -11, they're going down, right? They're getting even smaller. So these are all doing this. It's opening down, okay? Opening down. From here, -4 is my x, right? There's my x. What's my y that goes with it? -11. That's why we extend the table, okay? Same domain, always all real numbers. Got that. Okay, always all real numbers there. Range, that's our tricky one. Let's do that. Y, and then our y value of our vertex. Okay, now it's either greater than or less than. This time we're going down. So it's going to be less than or equal to. This is our maximum. This is our maximum. All of my -2, that's my bigger than all the other y values. So all my y values are less than or equal to that number right there, -2. Okay, the rest of this worksheet, so number 3 here in this one, 4, 5, and 6 over here where it says complete independently, those are all for you guys to do independently, like it says, independently. Okay, I'll be walking around. You guys know I'll be walking around helping people, so if you have questions, definitely refer back to the video. You got any questions? We got lots of good stuff that we did together. You should practice these things on your own as well as we're going along. Okay, we're going to be turning this in for a grade. So, for those of you who are still watching and still listening, you can go ahead and, as a bonus, you can go ahead and put stars around your name. So I'm going to write my name on my paper. And then if you go ahead and put stars around your name, that's an extra bonus. That's some bonus points right there, just for sticking with me and going through the whole video, making sure you're listening well, okay, and listening to the instructions. All right, excellent work. We'll see you guys, and you know, as you guys say, just like, comment, and subscribe because I'm supposed to say that apparently.